Here's a claim that sounds almost too strange to be true. The crash of 1929, the crash of 1987, the dot-com collapse in 2000, the 2008 financial crisis. Different decades, different assets, different causes according to every headline written about them at the time. And yet, if you strip away the news stories and just look at the raw shape of the math underneath each one, physicists have found something unsettling. These crashes don't just resemble each other. In many cases, they appear to follow the exact same class of equations. Not the same news, not the same trigger, the same underlying mathematics that physicists use to describe water turning into steam, sandpiles collapsing into avalanches, and earthquakes tearing through fault lines. Now, before you get too excited, I need to be honest with you up front, because this channel doesn't do hype without substance. There is no single magic equation that tells you the exact day a crash will happen. Anyone who promises you that is selling something. But the real claim, the one that's actually survived serious scientific scrutiny, is stranger and more interesting than a simple prediction machine. It's this: market crashes don't need a brand new explanation every single time. They may be the same old physics playing out again and again, of a system crossing a critical threshold. Stick with me, because once you see this pattern, you will never watch a calm market the same way again. Let's start with what physicists actually mean when they say a market crash isn't a news event, it's a phase transition. Here's the everyday version of that idea. Water sitting in a pot doesn't slowly, gradually decide to become steam. Nothing dramatic happens as you heat it from 90 degrees to 95 degrees to 99 degrees. Then, at exactly 100 degrees Celsius, everything changes. The entire system flips into a different state, almost instantly. Physicists call that a critical point. And the strange thing about critical points is that the specific molecule of water that finally tips things over doesn't matter. The heat had been building the entire time. That one extra bit of energy is just the final nudge, not the real cause. This is the lens Econophysics puts over financial markets. A crash isn't caused by one headline. The headline is just the final grain of heat. The real cause is whatever invisible pressure had already been building in the system long before that headline ever existed. And once you accept that framing, 15 deeply strange, deeply specific patterns start to fall into place. Let's go through them one at a time, because each one is a different piece of the same underlying picture. Let's slow down on this first pattern because it's the foundation everything else is built on. When most people watch a market crash unfold, they instinctively look for a cause and effect story. The Fed said something. A company missed earnings. A country defaulted. And that story feels satisfying because it's simple, and simple stories are comforting. But physicists studying critical phenomena ask a completely different question. Instead of what caused this, they ask, was this system already sitting near a threshold, primed to flip? Think about a pot of water again. If you ask what caused it to boil, the honest answer is almost absurd. Heat over time until a threshold was crossed. Not one dramatic event. A slow accumulation followed by a sudden discontinuous shift in state. That's the claim about markets. The crash isn't a reaction to news. The crash is a system crossing a threshold, and the news you remember is simply the moment the threshold happened to be crossed. Here's where this gets genuinely uncomfortable, and I mean that as a compliment to how good this idea is. If crashes are phase transitions, then the size of the trigger tells you almost nothing about the size of the crash that follows. A tiny, forgettable headline can trigger a massive collapse, not because that headline was powerful, but because the system was already fragile enough that anything would have done it. Physicists have a beautifully simple metaphor for this: the sandpile. Picture dropping grains of sand onto a table, one at a time. For a long time, nothing dramatic happens. The pile just grows. But eventually, the pile reaches what's called a critical state, steep enough, loaded enough, that it's sitting right on the edge of collapse. At that point, one single grain of sand can trigger a massive avalanche. Not because that grain was special, because the pile had already built up enough hidden stress that almost any grain would have done exactly the same thing. This is why, after every crash, you'll hear analysts obsess over what caused it, as if identifying the final grain of sand explains the avalanche. It doesn't. The real explanation is buried in everything that built up before that grain ever landed. This is where Econophysics stops being a metaphor and starts being genuinely strange. Researchers studying market crashes literally borrow mathematics from the study of avalanches, sandpile collapses, and earthquakes. Not as a loose comparison for a documentary narrator to say out loud as actual working mathematical models. Why would markets behave anything like tectonic plates or falling snow? Because all three systems share a common structure, many small local interactions, building tension gradually until a cascade releases that tension all at once. An earthquake isn't one giant, unprecedented event. It's countless small stress points along a fault line accumulating for years until the accumulated stress exceeds what the rock can hold. Then it releases, sometimes as a small tremor, sometimes as a catastrophe. The mechanism is identical in both cases. Only the scale of the release differs. That's the deep insight Econophysics borrows. Markets, like fault lines and sandpiles, are systems where many small interactions accumulate stress until a cascade becomes not just possible, but statistically inevitable. If you watched our last video on black skulls, this next pattern should feel like familiar, uncomfortable territory, because it's the same flaw showing up again from a different angle. Standard financial models often assume returns follow something close to a bell curve. Under that assumption, extreme events should be vanishingly rare, almost negligible, but real markets have what's called fat tails. Extreme crashes and extreme surges happen far more often than a bell curve would ever predict. Not slightly more often, dramatically, systematically more often. This is one of the most important reasons crash risk keeps getting underestimated, decade after decade, crisis after crisis. If your model assumes rare events are nearly impossible, you will consistently underprepare for the moments that matter most, because your math is quietly telling you they basically never happen, right up until they do. Fat tails aren't a side detail in this story. They're a symptom. They're the fingerprint left behind by a system that behaves like a critical, cascading process, not a smooth, predictable, bell curve-shaped one. Here's a pattern that changes how you should picture a market entirely. In physics-inspired models of markets, each individual trader is treated less like a rational decision-maker and more like a single particle in a much larger system. No one trader controls the outcome. The crash, the global event, emerges from millions of small, local interactions between these particles. That reframes the market as something closer to a living swarm than a machine with a control panel. Nobody is driving a crash. It emerges, bottom-up, from countless small decisions interacting with each other. And that leads directly to the most dangerous pattern in this entire list: synchronization. The most perilous moments in any market aren't when people disagree. They're when people start behaving identically, often because they're all watching each other, rather than watching any underlying fundamental value. Physicists call this collective alignment. In finance, we call it herding. We call it panic. Individually, everyone might feel like they're making an independent, rational decision. But when thousands of independent decisions all point in the same direction at the same moment, the system stops behaving like thousands of individuals. It starts behaving like one enormous, synchronized wave, and waves like that don't ease into a stop. They break. Now here's the pattern that should genuinely unsettle you, because it flips your intuition upside down. Volatility doesn't arrive randomly, spread evenly across time. It clusters. It arrives in bursts, long stretches of relative calm, punctuated by intense periods where the market swings wildly. That clustering pattern is one of the specific fingerprints physicists look for when studying instability building inside a system. But here's the truly counterintuitive part. In critical systems, a market can look calm right at the exact moment it's becoming most dangerous. Go back to the sandpile one more time. As the pile approaches its critical state, it doesn't necessarily look chaotic from the outside. It might look perfectly stable, smooth, symmetric, unremarkable. But underneath that calm surface, the internal stress has been quietly accumulating the entire time. A quiet market is not automatically a healthy market. Sometimes, quiet simply means tightly wound, and that idea alone should change how you interpret calm periods in any market you're watching. Calm isn't proof of safety. Sometimes it's proof of exactly the opposite. Here's one of the most unsettling ideas in all of Econophysics, and it directly challenges how financial news usually explains crashes. We're conditioned to expect that every crash needs an external villain, a war, a default, a scandal, something from outside the system that knocked it over. But one of the field's most disruptive ideas is that crashes can be endogenous, meaning the market can generate its own crisis internally without needing any major external shock at all. That completely reframes the question you should be asking. Instead of what news caused this crash, the better question becomes, how fragile was this system already before anything happened at all? And there's a genuinely useful early warning signal buried inside this idea: rising correlations. As a system approaches a critical point, different assets often start moving together far more strongly than they normally would. Assets that are supposed to be unrelated, different sectors, different countries, different asset classes entirely, begin behaving as if they're the same asset. If that sounds familiar, it should. That's almost exactly what happened during the long-term capital management collapse we covered 2 videos ago. Supposedly unrelated positions all moving together, violently, in the same direction, at the same moment. Diversification is supposed to protect you by spreading risk across things that don't move together. But rising correlation means diversification can quietly fail at the precise moment you need it the most. This next pattern is, without question, the strangest and most specific claim in the entire field, and it comes from a model developed by physicist Didier Sornet and his colleagues, known as the JLS model. The claim is this: as a financial bubble approaches its breaking point, it doesn't just drift upward in a smooth, boring line. It can develop accelerating oscillations, small wobbles up and down that get faster and faster, closer and closer together, as the system nears collapse. Picture a spinning coin slowing down on a table. At first, it spins smoothly, evenly. But as it loses momentum, the wobbling speeds up, faster, tighter, more erratic, right before it finally clatters flat. That's the visual signature the JLS model looks for in bubble prices. Not a smooth climb followed by a sudden crash, but an accelerating rhythm of smaller oscillations layered on top of the climb, compressing in frequency as the system approaches its critical point. I want to be careful and precise here, because this is exactly the kind of claim that gets oversold. This pattern is not a crystal ball. It doesn't hand you an exact date. What it offers is something more modest and, frankly, more scientifically honest. A mathematical signature that, in some historical bubbles, has appeared before the collapse. That's a genuinely different claim than "this equation predicts the future," and the difference matters enormously. 2 more patterns, and both point toward the same deeper idea: structure hiding inside apparent randomness. The first is self-similarity, the fractal-like idea that market behavior on one time scale can resemble market behavior on a completely different time scale. A 5-minute chart can echo the same rough shape as a 5-year chart. That's one of the core reasons crashes feel chaotic and unpredictable in the moment, while still being mathematically measurable when you zoom out and study the underlying structure. The second is percolation, a concept borrowed directly from physics. Percolation asks a simple question: when do disconnected pieces of a system suddenly link together into one continuous, connected path? Think of water slowly seeping through a rock, isolated droplet by isolated droplet, until suddenly, one final connection completes a path all the way through. In markets, The equivalent question is this: when do small, isolated failures, one fund here, one over-leveraged position there, suddenly link together into one system-wide cascade? Individually, each failure might be containable. But once enough small failures are connected, the entire system can complete a path from top to bottom almost instantly. And there's a dangerous companion effect layered on top of both of these ideas. Liquidity can vanish faster than prices actually fall. A market isn't just a collection of prices. It's also the ability to trade at those prices. In a fragile, cascading state, that ability to trade can dry up abruptly, which makes the crash self-reinforcing. Selling becomes harder to absorb exactly when everyone is trying to sell at once. Now let's land on the idea that ties every single pattern in this video together, because this is the part that's actually revolutionary and it's not what most people assume. In physics, wildly different systems, water turning to steam, magnets losing their magnetism, sandpiles collapsing, can obey the exact same underlying equations near their critical points. Not similar equations, the same equations. Physicists call this universality, and it's one of the most beautiful and strangest results in the entire field. That is the deep reason Econophysics gets people excited. Not because it hands you a magic equation that predicts every single crash before it happens. It's because it suggests that market crashes might belong to the same universal family of behavior as earthquakes, avalanches, and phase transitions, different systems, wearing different costumes but obeying the same fundamental mathematics underneath. That reframes the entire question you should be asking about markets. Not what's different about this crash, but what's the same about every crash. Criticality, scaling, cascades, synchronization, fat-tailed risk. Different headlines every single time. The same underlying physics, again and again. So here's the sentence I want you to actually remember after this video ends, because it's the single strongest, most defensible idea in the entire field. Market crashes don't need a new explanation every time. They may be the same old physics of a system crossing a critical threshold. That's a bold claim, but notice what it isn't. It isn't a promise that you can predict the next crash's exact date. It isn't a magic formula you can trade against tomorrow morning. What it actually offers is something quieter and in some ways more valuable, a framework for asking better questions. Instead of chasing headlines after the fact, you start watching for the things that actually matter beforehand: rising correlations, clustering volatility, deceptive calm, and a system that's been quietly loading tension long before anyone noticed. The next time you hear an analyst confidently explain exactly what caused a crash, remember the sandpile. The headline they're pointing to might just be the final grain of sand, not the real story. The real story was already loaded into the system, long before that grain ever fell. If this kind of thinking, where physics quietly explains the parts of finance nobody else is willing to explain, is why you're here, subscribe, because next week we're going somewhere completely different, calculating the actual physics of scarcity hiding behind Bitcoin, and why it might be thermodynamics wearing a costume nobody's talking about. See you then.